What is Modbus? It's a communication protocol that operates at the application layer of the OSI model. It was created in 1979 by Modicon for its PLCS and is still widely used in industry today. In RTU, it follows a master-slave architecture, while in TCP/IP, it works as client-server. Its main advantages: it's public, free, easy to implement, and handles data blocks without big limitations. The downside of RTU is the lack of security against unauthorized commands, but in TCP/IP, this is mitigated by network layers. Modbus can run through USB, RS-232, RS-422, or RS-485. These are not protocols, but electrical standards located in the physical layer of the OSI model. The most common is RS-485. It uses 5 volts, is differential, multi-point, and balanced, with 2 wires and a 220 ohm resistor. It supports up to 256 stations on a bus up to 1,200 meters long. Communication is half duplex, meaning it can transmit and receive, but not at the same time, something very common in industry. Modbus registers. The protocol defines 4 main types of registers: discrete inputs, read-only, 1 bit, addresses 1 to 10,000, coils, read-write, 1 bit, addresses 10,000, 1 to 20,000, input registers, read-only, 16 bits, addresses 30,000, 1 to 40,000, holding registers, read-write, 16 bits, from 40,001 onward. When programming, we create a Modbus map with the register name, type, address, and data. Data types can include 8-bit or 32-bit integers, floating point values, bit fields, and more. Typical configuration: the port is usually set to 8N1, 8 bits, no parity, 1 stop bit, although some actuators use 8E1. Baud rates commonly range from 9,600 to 38,400. The Modbus frame includes start, address, function, data, CRC, and end. On the serial monitor, we see numbers from 0 to 255, each with a specific role. Libraries handle the framing, but with experience, you can tell if something is off by looking at the raw data. In short, Modbus is a simple, robust, and universal protocol for industrial applications. In our next session, we'll do a basic practice exercise, first with common industrial software and then with a more advanced example. See you next time.